We are now going to talk about equally likely outcomes. So if the sample space for an experiment contains n outcomes, all of which are equally likely to occur, we assign a probability of 1 on n for each outcome to each outcome. Then the probability of event A is given by, so the probability of A is the number of outcomes of A divided by the total number of outcomes. So let's go through an example now, which will explain what all of this means. So suppose a number is drawn at random from the numbers 7, 8, 9, 10, 11, 12, 13, 14. What is the probability of choosing a prime number? Okay, so let's call this the probability of choosing a prime number, the probability of A. What we're going to do is figure out the number of outcomes in A. So that's choosing a prime number. So that would be 7, that would be 11, and that would be 13. So there are 3 prime numbers there. So we put a 3 in our numerator. And then as you see down here, our denominator is just going to be the total number of outcomes. So just the sample space. So the amount here we have is 1, 2, 3, 4, 5, 6, 7, 8. So the answer will just be 3 on 8. So the probability of choosing a prime number is 3 on 8. Nothing special there. You've seen that before in previous years. All right, let's continue on here. Next, rules of probability for finite sample spaces. So the probability of A is greater than or equal to 0 for each event A. The sum of the probabilities of all events, sorry, let me read that again. The sum of all probabilities of all the outcomes of a random experiment must be equal to 1. All right, let's read through this example here and it will make sense of what we've just read here. A random experiment may result in 1, 2, 3, or 4. If the probability of 1 is equal to 1 on 13, the probability of 2 is equal to 2 on 13, and the probability of 3 is equal to 3 on 13, find the probability of obtaining a 4. So what we need to utilize here is this line right here. The sum of the probabilities of all outcomes of a random experiment must be equal to 1. Meaning if I was to add the probability of getting a 1 or a 2 or a 3 or a 4, all of those are going to be equal to 1 because they're my only options. So there's a 100% chance that I'm going to roll, or the experiment will result in 1, 2, 3, or 4. So to find out what the probability of 4 is going to be, what I'm going to do is I'm going to go, the probability of 4 is 1 minus, and then here I'll just add all together these. So I'm going to subtract the addition of all of these. So 1 on 13, 2 on 13, 3 on 13. That will be 1 minus 1, 2, it will be 6 on 13, will it not? So that means my final answer here will be 7 on 13. So the probability of getting 4 out is 7 on 13. So let me highlight that. And again, that makes sense because if I went 7 on 13 plus 1 on 13 plus 2 on 13 plus 3 on 13, I would get 13 on 13, which is 1, which is like, it's definitely going to happen. Okay, so that is equally likely events and rules of probability for a finite sample spaces.